Okay, well, let's get started then. So thanks for joining the second webinar for the Smart Cities Hackathon. I'm just going to quickly share my screen and get up the presentation. Cool. Great. So yeah, thank you for joining the Smart Cities contest technical webinar. Previously, we had the kind of overview and a bit of an introduction into the use cases and what the contest was all about. We had a really good response from that, and it was great to see so many people asking questions. So just to preface, if you have any questions that you have on maybe related to your projects or related to any project ideas or anything like that, I'd suggest you write them in the chat, and I'll get to them at the end, and we can have a discussion about you know, some of the issues you're facing, or if you need any help with anything in particular. So to introduce myself, my name is Lewis Freeberg. I'm the Director of Ecosystem at the IOTA Foundation. What that means is we primarily deal with the developer community. We have a very large Discord with about 20,000 people on it. We have a large Reddit and Twitter presence. So my role is to work with my team and produce content for the various community members we have, whether that be live streams like this or webinars, as well as producing documentation, content, and things like that. So today I'm going to talk about just the basics of what is IOTA. So if you missed the first one or haven't seen any videos about it, you'll have an understanding of just kind of the very, very basic of what IOTA is. And then we'll jump into the themes. So on the Hackster contest page, we have a list of the different themes that we have in the contest. And I'll go in there and decode the challenges a little bit and propose some projects that can be done. I know we're relatively late in the contest and with a week left, but I thought it would be useful to go back and discuss some of the different ways in which you can interpret the challenge statements and create projects that would be doable in the last week of the contest. And then we'll do a little bit of coding. I've got just a simple device here, Raspberry Pi with an environmental sensor on it. And we'll do a bit of exploration around a simple use case that can be done that fits one of the challenges. And we'll be able to interact with IOTA, publish information and that type of stuff using environmental sensors. And then finally, we'll move on to the Q&A. So what is IOTA? So back in 2015, the IOTA founders saw the scaling limitations of blockchain approaching. And so instead of proposing second layer solutions, what they did is they went and created a new structure for a distributed ledger. And this structure was called the Tangle. So instead of the Tangle being a blockchain, which is literally just a chain of blocks with a new block being added to the end of the chain every so often, what they decided is that each individual transaction would reference previous transactions and allow you to publish transactions in a more fluid manner. So the reason why they did this was for a few different reasons. So instead of having a block that you had to fill and then wait until it was published and then continue that process, what they would allow is for individuals to publish new transactions whenever they required them. And then as people continue to add transactions to the network, your transaction would be confirmed in turn. And so the reason they did this was allow for a larger throughput on the network, but also they allowed for there only to be one type of user on the network. So in a blockchain or a proof of work chain or a proof of stake or anything like that, you have generally a validator and a user. A miner and a user. And with that, you have to basically pay a fee to the miners in order to have your transaction included in the next block. In IOTA, there's only one user class where individuals who want to publish transactions do the validation themselves. And this type of fee, which is a small amount of computation, allows you to publish transactions for free. So you don't need any IOTA tokens to be able to interact with the network. And what we'll do today is we'll just go through a small example of just publishing and fetching data and exploring how the developer tools look. This is quite unique in any type of distributed ledger system, especially permissionless ones, where not often are you able to interact with the network, i.e. send transactions and receive them. without having any of the tokens in your wallet or anything like that. So what we'll do is, we'll have a look at that a little bit later. So to give you an idea of what this looks like, so that little graph that I showed you before with all of the individual transactions, this is what it looks like kind of in real life or actively. I understand this is a representation, but this is the main net of IOTA. So this is taken a few months ago when there were a large amount of transactions coming through. And so this is a visualizer where you can see individual transactions being added to the end of the chain. And then as they continue to be added, your transaction will be selected in turn and be buried in the tangle. And so the network continues kind of on forever in an uninterrupted pattern, and more transactions are added onto the end. The slides will be shared at the end of the presentation, but you can go and have a look at this website here, and you can see the tangle operate in real time. And this also visualizes the mainnet, the developer network, and the span network that we have. So you can go and have a look and see how things are going. So what does the IOTA protocol offer? So because of the new data structure, it's highly scalable. Because of the single user class, it's zero fee. And we also designed this to be useful on IoT devices. So we had low resource requirements. So individual devices like a Raspberry Pi or even smaller are able to interact with the network by creating transactions and sending them to a full node. So this could be something slightly bigger than a Raspberry Pi can be a full node operating on the network. And they're able to interact in that way and still have the full benefits of interacting with the network. We also have secure data transfers. So in some distributed ledger networks, you're unable to add any data to transactions, and sometimes it's actively discouraged. Where in IOTA, we understand that if we want to make a network usable for small devices, instead of having them go off band and fetch information separately from the value transfer network, which is the IOTA tangle, why don't we enable that to be one and the same? So whenever you send a transaction in IOTA, you either choose to put a signature in the message field, or you can put data in that message field. And so you can have devices using applications that purely run with the data and value in IOTA transactions, so publishing advertising messages and receiving payments for them, and then providing informational services from those. And then finally, we have quantum resistance. So this is the ability for the IOTA signature scheme to stand up to attacks from quantum computers. Given that we're focused on IoT and focused on building out a value and data transfer network for that area, we want to make sure that once these devices have been provisioned, once they're out in the field and quantum computers come around, that the cryptography isn't broken immediately, and we have to basically scrap all of these insecure devices and reissue them again. And so this was kind of a future-proofing mechanism, and you can't really test if a quantum resistant signature scheme works until quantum computers exist. But given our understanding of that area, it's said to be fairly resistant to those types of attacks. So as we've seen from the Hackster contest, if you've had a look at the page, you'll see a number of these industries listed. And so IOTA is quite interested in the way in which machines interact with each other, whether that be for specific business use cases, sharing information, things like that. And there's a few areas in which we've identified that we are particularly interested in. So the first being smart mobility. And so this was the first challenge area in the Hackster contest. So thinking about how we can enable vehicles with their own wallets to be able to interact with humans and other machines in interesting new ways. So thinking about parking payments, thinking about the data generated from the vehicle and what you can do with that, as well as looking at things like maintenance, ride sharing, tolls, all of these different examples that the car can then become its own kind of economic agent. And then maybe when you throw in autonomous driving, you start to have this vehicle that's able to go out into the world, pay for charging, receive money for ride sharing services, pay for cleaning, these different types of things. And it becomes its kind of own entity apart from you, which is quite an interesting and scary concept. Something that goes hand in hand with the future of mobility is smart energy. So when you think about the increase in electric vehicles, and the way in which that will affect the grid in terms of all these vehicles charging at night and being used rather than fossil fuels. You start to have, the cross-pollination of these two areas. But not only thinking about mobility and energy, but also, how grids are run in terms of, incentivizing people to balance the grids. So whether, a household is using too much energy in a specific area, you can incentivize it to maybe turn off some lights or something like that. And instead of using peak power, you can use a cheaper method of just incentivization to have things like that happen. So these are just some interesting business models or ways to think about how you could introduce payments into different industries that previously weren't kind of receptive to that, and start to change how the industry operates. Similarly, we have e-health and supply chain and smart factory. These are areas that aren't particularly focused on in the contest, but I think they're interesting and worthwhile to take a look at if you're interested in IOTA itself and in distributed ledgers in general. There's a lot of interesting work being done in the space. And you can check out on our website or in our documentation portal of blueprints relating to how a smart supply chain might look. Similarly with e-health and things like that, you can go check out those examples there. But that's not to say this is an exhaustive list. There are many, many different ways in which IOTA can be used in various areas, and similarly distributed ledgers in any area. And so it's quite exciting to see the different use cases being brought to fruition, and hopefully we'll see some interesting things come out of the Hackster contest. I know I've seen a few entries, but I'm excited to see the more that are coming. So let's dive into the themes and some of the projects that are possible with them. So we'll focus on the first one, which is smart mobility. And so, okay, cool, yeah. Group Renault posed a challenge for the smart mobility space. They provided a very nice explanation of kind of setting the scene for the challenge. But the challenge itself focuses on the way in which you can use distributed ledgers or their value component to kind of publish tender purchase information that are relevant to vehicles out on the road, large fleets like government, things like that. So they said that they wanted to have an understanding of the car data needs from different actors and the way in which you might share data between them and whether that might be incentivized or otherwise. So the way in which you can kind of deconstruct this and look at possible solutions is, one example I could think of is simulated vehicle data, which is published in an encrypted messaging stream. We call these MAM streams to the IOTA network. And the reason why that would be useful, so this could be, like G-forces, acceleration, odometer, braking, things like that. This could be sent out to insurance companies and have an immediate adjustment to your premiums as you drive. So this is something which might, greatly reduce the cost of insurance throughout the year, given that insurance companies have to base their risk on the worst possible outcome. So if you're a safe driver and you can prove that you're a safe driver, then you might be able to receive a lower kind of premium in order for you to have to insure your vehicle. So this is something that could be achievable using something like this. So using a motion sensor or even a little vehicle or something driving around, you can have that send messages to the network, and then have another device be able to read that back, or a computer program, and be able to kind of create a dashboard of information and then do a risk profile based on that. So, if the vehicle has, run into any walls or anything like that, you would obviously increase the risk and adjust the price that the vehicle needs to pay the service in order to have insurance. Similarly, what you could think about is, instead of looking at direct actors, what you could do is open up the data for various actors to use. So you take the data coming from a device and start to publish it into, again, an encrypted stream. What you could do is you can advertise what information you have, where you are, that type of stuff, and then have a mechanism for people to purchase that information from you. And so this is kind of looking at that, sharing of information within an ecosystem. So looking at how you might request payments and how you might send payments. There's a few examples already in IOTA, looking at things like smart vehicle charging, which I touched on in the last webinar. But there are interesting ways in which you can have, devices exchanging value and data. And I think this would be an interesting submission, especially to the smart mobility case. And then finally, one that looks a little bit more like the public good. So thinking about taking location-specific data. So looking at road hazards, traffic information, roadworks, things like that. This could all be simulated, or you could have like a little track running or something like that. And tagging that information with an area code. So if you could imagine a whole fleet of vehicles driving around, all the information that they're going to be gathering is quite vital in terms of figuring out the way to get to a specific location. If you have crowdsourced information along that route, you can know the weather not the weather. You can know the traffic patterns. You can know if there are any issues up ahead, and you can reroute accordingly. And so this is an example of maybe you could monetize, but would be something that would be good to share information for improved commuter experience. And as everyone is sharing this information, the better and more efficient the traffic systems within our cities can operate. So let's move on to smart energy. So this is posed by Birds. And so this is a really good one because it has a number of different smaller challenges that you can kind of look at and see how you could apply for. So they're looking at new models in which they can reduce energy consumption and make operations of cities, homes, businesses more efficient. And so they pose a number of different challenges, which is really good. So they've posed one which looks at green energy certificates, so production of energy and how you can prove where that energy has come from. Given the recent rise in environmentalism and looking more at where your energy comes from, there's a big push to start using renewables and solar, even if there is a higher premium for that. So that's a really interesting one that you could think about doing on one of the submissions. So an example of how you would do that you'd have multiple devices. One can be a producer, so you could even hook up a small solar panel to one device, and you start producing information that you publish to the network. So this is kind of like an audit trail or a history of the device. And so if they're producing electricity from a specific source, whether that be through wind, solar, whatever, they can publish that information and then share that for a later date when you want to verify where that information is coming from. Similarly, once that information has been published, a grid would be able to take that energy and start publishing how it distributes around that. So you have a history of where it was produced, how it was distributed, and then you could finally have the customer knowing exactly where their energy is coming from, but also be able to publish their consumption usage as well. And this would be useful back for the grid operators and the governments to be able to figure out the way in which power is used and verifying that the energy that you're using is green. Similarly, they pose a number of other challenges looking at energy trading. So the way in which you might advertise and purchase electricity. And so this is a similar concept to the data marketplace that we had in IOTA. And so this is a simple two-sided marketplace where you have people selling sensor information and people who want that information purchasing it. And so this is the same type of concept, just looking more at energy rather than data. And so you could think about a way in which you have, producer and consumer of energies, two devices negotiating payments between each other. So saying I have energy to sell, and then being able to receive payments directly from the other device in exchange for that energy. And in terms of making a demonstration, you could do quite a cool one where you actually have the device be able to charge the other device using, say, MOSFETs or something similar to control the flow of energy from one device to the other. And then finally, looking at demand balancing, I think this is actually a really cool use case. So looking at the way in which energy demands fluctuate throughout the day. So when grid operators, energy producers produce energy, they need to know what times of the day are peak and they need to put on capacity for that. When you have a large number of individual users throughout a city, you don't really know what's happening within homes in order to change the draw of electricity throughout the day. So individuals themselves might elect to publish the information relating to their consumption throughout the day. And then this information could then be collected. You could analyze it to figure out, where the peaks and troughs are, and then you could start to predict when energy will be used or not. And because of that, you can purchase and sell electricity and be able to have demand met rather than using the high-priced peak power plants and stuff like that. So an example of how you would implement that is looking at a small number of devices that would be able to publish their consumption information throughout the day. That could be read back by another device who makes inferences on when there should be more electricity and when there shouldn't be. And I think that would be quite an interesting case that would solve that challenge. Then looking at smart buildings. So this was an interesting one, looking at how you can optimize the efficiency within buildings, and also look at how you can have a view of like predictive maintenance and making sure that the building is in good condition. So this is interesting for a number of large companies that are looking at the way in which they operate buildings and make sure that they're managed correctly. So the way in which you could kind of solve these issues or this problem relating to the hackathon is starting to look at what building data there is. So you could think about using a motion sensor or a camera to detect presence within rooms or an individual room. And then what you could do is you could use the Tangle to do command and control of different sensors or different kind of like lights or fans, or which is analogous to like an HVAC system in a building. And then what you could do is you can create that audit trail of when devices were turned on and off, how the building is using energy and those types of things. Another one which would be really cool is looking at proactive maintenance. So when you walk around a building, you can sometimes notice that there are things a little bit amiss. One good example that you could build is looking at how a light might go out. So you look at a globe that's in the roof. If the light goes out, then it's no longer drawing any power. So what you could do is you could simulate a light that's gone out. So you measure the reduced current draw, and then you advertise the price to replace it. So you could tender a contract on the distributed ledger saying, hey, I'm a building X. I know this light or a light in this room has gone out. We use these lights. Send me a response in a transaction that says how much you're willing to solve this problem for me for. And then the building would be able to choose the best offer within a certain time period and be able to pay for that that service, and then settle up at the very end as well. And so this is actually a really cool one, considering that you can have these buildings that are, or like you can have these entities that aren't kind of interacted with by humans, or like they're not controlled by humans in that sense, but they are able to understand or sense their environment, and then do transactive things to make them come back to a working condition. And so this reduces the requirement for like human intervention in terms of having management and stuff like that get involved. And I think this would be really, really cool to see actually in the real world, and I think this would be a good step towards that. And then one other thing is looking at an audit trail for equipment within buildings. So looking at HVAC systems, energy distribution, things like that. So these pieces of equipment are actually usually quite expensive, and having something wrong with them can pose quite a problem for those that are doing building maintenance and stuff like that. So having an audit trail or having an active maintenance or an active eye on what's happening with certain machinery inside a building would be really, really good in terms of predictive maintenance. So figuring out if there's something wrong with the system. It might not be a large change, but it might be a slow degradation, which you can then action upon. And also for warranty purposes, figuring out, is this, falling within warranty? Is there a fault from the manufacturer? And being able to publish an audit trail of history of things that are happening within the building that you can then have a bigger picture when you want to fix it or when something eventually goes wrong. And so those are some interesting ones that you can do for the building management. And then finally, looking at smart districts. So this is a little bit wider. So you have mobility, you have energy, you have buildings all within a smart district. And so it's really about, moving out to the macro view and tying all of the different things together. And so what they're interested in is looking at how IOTA could be integrated into other technologies. So interoperability is a big thing in the distributed ledger space. Distributed ledgers themselves aren't kind of like the cure-all, or they aren't the solution to everything, but they are a tool to be used among other solutions. So integrating IOTA with other technologies such as like Azure IOTA or something like that, would be an interesting way of augmenting the ability from somebody who has a large number of sensors, and then making sure that there's the sale or purchase of that information, or doing something like an audit trail to verify that that data is correct and coming in okay. And then you can think about the way in which you might have marketplaces between energy providers and charging stations, as well as looking at how you might build up a kind of a parking simulation as well. So with that, you could think about the purchase and resale of energy between devices. And as I said before, you could maybe set up a demo where you control the energy flow among devices and have them purchase that information and maybe charge or balance their batteries. And then also thinking about a parking scenario. So looking at a parking business where you have a number of different spots available, and these might be at different positions around a geographical area. They have different prices associated with them. And then you have another device that is able to read those empty spots from the tangle, and then be able to pay for the time spent in one of these spots at a specific price. And so this would be an interesting use case in terms of how you would manage parking spots within the city. So those were the different use cases in which you could these are the different use cases you could apply to various different areas. And I think it was particularly interesting and definitely achievable in terms of what you would be able to build to demonstrate how you would integrate IOTA into these scenarios. So what I'm going to do now is I'm going to do a quick kind of example. I've written up a little application that takes sensor information from the environment through a Raspberry Pi and publishes it directly to the Tangle. And then it watches an address to see if there's any activity. And then this use case could be extended out to look at publishing information and then having somebody do a purchase request and then sending them back the access or where they could find that data at a later date. So this could deal with the two different use cases, whether that be the smart district or the smart mobility. And the solution uses a Raspberry Pi with a sensor hat. So it has like a 9 DOF sensor, which is pretty fully featured. But it just uses the temperature for this one, but you could extend this to many different kind of sensor streams coming in, or this could be like CD, looking at how many people are in a room or something like that. Use simple transactions to publish information to the Tangle. And then what we're doing is we're using a zero message queue, which is similar to like an MQTT or like a WebSocket that listens for payments from the network, from a node. And then you can action items on that rather than having to check every minute with a HTTP request for data back. And so really it's quite basic. It has two functions. One is to read data from the device and publish. And then the other one is to, when there is an address when there is a payment at a specific address, then do an action. And so it looks kind of like this. It's not too complex at all. You have two streams coming from the device. One is to publish the information to like a data address where it's kept. And the other one is to do an advertisement and watch that address in terms of when people want to receive data, and they would pay to that address, and then you would get a notification and the device would be able to provide access to that information. Cool. And so this very, very simple code has been put up at the IOTA community address. Again, I'll publish this video with the slides to the Hackster discussion page in the next few hours. And so you can go back and have a look at this, or you can just quickly grab the URL and go from there. But it just uses a combination of Python and JavaScript to be able to execute this use case. Okay, so what I'm going to do is I'm just going to go back to here. Okay, so I think I'm sharing my screen. I'll just double check that one. Yeah, okay, doing that. Okay, so what I have here is very simple, just like a Raspberry Pi 3, and it uses a environmental sensor hat from Pomeroni. So it's just connected via Wi-Fi to my home network, and I'm SSH'd into it here. Let me clear that. Cool. Great. So what I've done is I've gone through just what I have here. So I've gone and cloned the the repository into the home folder of the Raspberry Pi. And I've also pre-installed the Pimaroni examples. So the temperature hat itself has a bunch of drivers and stuff that need to be installed, and that's using Python. So once I've git cloned the example repo here, we'll cd into it. And then in here we can find a bunch of the different files which are required. And so what I did is I did an npm install because I'm using JavaScript. I'm more familiar with JavaScript, so this example is easy for me to do. And then once you've installed that, it takes about like 5 or 10 minutes, depending on the speed of your Raspberry Pi, because there's quite a few dependencies in terms of Node.js. But you could definitely do this in Python, and there's a IOTA library, which I can link to, which I know a number of you are using. So what you could do is you could do this completely in Python, but because it's in JavaScript, just because I'm more familiar with it. Okay. So what we'll do is we'll take a look at the code itself. So this is just a simple modification on the temperature sensing example from the hat. So all we're really doing is we're taking the environmental temperature data, and then we're just writing this to std out. So this script, when you execute it, just gives you back a temperature reading. So if we go and do this right now, it should just give us the temperature reading. So it's not nicely formatted, so it doesn't have a new line or anything like that. And that's by design so that we can execute this from a Node.js script and then read the output into the Node application immediately. So in this, so this function here is then called by my JavaScript application. And so what I did is I just built a simple function which creates a promise that then spawns the child process and calls the file, which is the temperature file, and then just waits for some data. And then once the data's been sent through, it finishes the promise, converts it to a string, and sends it back to the main application. So the main application, this is where it gets a little bit more complex. So I'll just quickly walk everyone through how this looks. So what we have here is we have that temperature reader. So this is just being required in. And we also have another item in here, which is the ZMQ watcher. So this is the message stream looker that we'll talk about later. We'll get to last. And then what we've got here is a whole bunch of IOTA related code. So what we're using is the JavaScript library from the IOTA core libraries. We have a converter, so we use a converter to change characters into something that is formatted for the IOTA transactions. We create an API. So with the library, what we have to do is we have to initialize it, and we have to tell it who to talk to. So the IOTA network itself is comprised of all these different nodes. And when you want to interact with it, say read information or send information, you have to connect to one of these nodes. And the main way of doing it is just through HTTP. But these libraries wrap that and allow you to do a lot more functionality than is just possible with the normal API from these nodes. So what we've done here is we've selected the DevNet node. So this is the node that most of you should be using if you want to interact with the IOTA DevNet. If you want to, you can interact with the mainnet. There are a number of different nodes available for that, but I would suggest doing the DevNet. It's a lot quicker and a lot easier to get started with. And we also have a faucet, which you can see here, that you can have a look at. You can get some tokens from and start to use it in your paid use cases. Cool. So with any IOTA transaction, you have a seed. So this is just a random string of 81 tries. So this is a specific set of characters, which is uppercase A to Z plus the number 9. And so these are the characters that you can use for your seed. And we also have an address, which we call the data location. So this is where we'll publish information to. So this is a whole bunch of setup that I've just gone through, but basically grab the library, initialize it, and then have some variables that we'll use later. Okay, so what we'll do is we have two main functions here. We have send transaction and send temperature. And this one we'll look at a little bit later. But what we do is we have a timeout, which basically starts the process. So with this application, what we want to do is every 20 seconds, we want to send a transaction to our data address, which records the environmental data and then publishes that to the Tangle. So actually what I'll do is I'll just run this in the background. So let's start this by going node index so we can see some transactions going up. Cool. So what this is doing, this is starting, it's going to wait 20 seconds and then it will go and publish a transaction. So we call send temp. So what we do here is we use this function to capture the temperature. So this is using this Python script up here, this function up here, which calls the Python script, which then grabs the data. We then convert this to a message that we want to send. So we say temperature data, convert it to a JSON string, convert it to the characters that we can use in IOTA. Then that creates our message. Then what we do is we add this message into our message field for our transaction, and then we send the address. So the address where we're going to send the data to is called data location. So this is just the location we'll send information to throughout this demo. And then once we've done that, we've constructed the transaction kind of array. We'll put this into the send transaction function, and then from there we then send that. Oh, I think I've doubled up some code here. Let's remove this. From that, we send transactions. Yeah, cool. We send the transaction using this function here. So these functions may look a little bit like daunting and you don't know where to find them. But last time on the webinar, I shared a resource which is really, really useful for people who want to understand the way in which you would send transactions and things like that. I use this called the IOTA workshop. So this is a simple repo which just has a whole bunch of JavaScript examples going from sending a transaction, receiving it, sending more complex data, creating addresses to receive tokens on, sending tokens, sending encrypted messaging streams, and also listening for transactions on the network. So then that's been publishing data to the network. So if we have a look over here, we can see these transaction objects. Say transactions transfer successfully sent. What we can do is we can take this address, go to an explorer, which is up here, and we paste in the address, search for it. And what this will do is this will show us all of the transactions at this address. So if we look here, we can see a number of different transactions. And if we click on them and scroll down to, and scroll down to here, we can see the temperature being published to the network. So this is accessible to anyone because it's not encrypted at the moment. And you can add that if you want to. But if you go to this address, you'll be able to find the transactions that you've sent and read them back at a later date. So that's just the simple way of publishing the information to the network. And I'll quickly touch on how to listen for transactions. So when we start the script, what we're also doing is we're calling this function, which is called init. So we're just initializing the ZMQ watcher. And so this is coming from this file over here. And in here, what we do is we basically are subscribing to a specific address. So we have an address called, pay address that we are listening to transactions on. So we're using the ZMQ stream. We're talking to the DevNet ZMQ server. We're then subscribing to the specific address. And then whenever we see a transaction on that address, what we'll do is we'll use the callback that we have, and then we'll be able to initiate an action. So if we go back to here, we can see that we have this is our callback. And in here, we're just doing, a new message found. And so what I'll quickly do is I'll quickly send a transaction in here, which will then trigger that function. So we do it's 5.1, I believe, and then we send that. And what we'll do is we'll send a transaction to that address. And then we have to wait a little bit because it's not immediate. But what will happen is that the device will register that there's been a transaction at that address. And then you'll be able to add logic in to be able to provide a transaction back to the person who's sending you a request or something like that. And I realize I'm going over time a little bit here. So what I'll do is I think I've covered, what the code does and how it functions. I've also got the code up on GitHub for you to have a look at later. And what we'll do is now is we'll just go back and have a look at the presentation and get back to the questions after that. Cool. So in terms of some other resources, if you kind of stuck and looking for some information, you can go to our documentation. We have a really, really large list of different client libraries and also some other programs that'll help in terms of token management and stuff like that. But if you're really stuck, this is a good resource to go to, and it'll be able to help you out quite easily. What we also have is we have Twitch streams. So Dave is really great, and he's worked on a number of different beginner tutorials and stuff, as well as some more complex stuff like setting up your own DevNet and things like that. If you really want to, you can go and have a look at him, and he does like 2-hour long videos that walk you through like everything that needs to happen in order to get an application set up. And those are mainly hosted on the IOTA Foundation YouTube, so you can go and have a look at that and be able to track there. And yeah, so what I'll do now is I'll just do some quick question and answer, and then we'll be able to hopefully help you out. So let me just turn off the sharing. Stop sharing. Okay, cool. Okay, so yeah, if you have any questions, just make sure you publish them in the chat, and I'll be able to get to them and have a look. I'm not sure if I have disabled the chat, but if you want to, you'll be able to put a message in the chat here. Okay. Yeah. Okay. Well, if there aren't any questions in terms of you know, any of the use cases or any of the problems that you guys are having, I'm going to be around on the discussion page. So if you have any issues or any questions, you can send them directly to me, or you can put them on the discussion page. I know that there's some direct messages that I've gotten from other people figuring out how to do certain things. Like there was an issue with a Python library, and I was able to provide them with a code snippet that they could use and modify. So if you have any questions or anything about how you would work on any of the solutions, please just let me know and I'll be able to help you out there. Yeah, so I just got a message relating to does this contest require extensive hardware integrations? Given the time constraints of the contest, I know it was quite short for a Hackster contest. Usually there's a few months involved and generally some hardware involved. I don't think it's a hard requirement that you have to use hardware. The items that I was talking about before, doing like, you know, battery balancing and things like that, they require some specialized stuff, and it usually takes a couple of weeks for things to come. So I'm not expecting there to be extensive hardware integration. Simulations can work, but I think it would be good if you were able to at least have some type of hardware interacting with IOTA as well. Cool. Yeah, so if there aren't any other questions, I don't think I'll keep you any longer, and we'll just call it here. So thank you for watching the second webinar, and this will be uploaded to YouTube relatively soon, as well as the slides be shared as well. So thank you all for joining me on a Friday evening if you're in Europe, or Friday morning if you're in the US, or 1 a.m. or 2 a.m. in Asia. So yeah, thank you very much, and hopefully I'll see your submissions. Thank you. Bye.